We are going to talk about logarithms, and logarithms are the inverse of an exponent. What I mean by that is if we have an exponent, that is, say, 2 to the third equals x, that's the same thing as saying we have 3 factors of 2 equals x. So we have 2 times 2 times 2 equals x. So we get 2 times 2 is 4, times 2 is 8. So we have x is equal to 8. Now, a logarithm asks a slightly different question. It says if we have 2 to the x equals 8, solve for x. And the standard notation for a logarithm is you take the base here. You start off with saying logarithm of. Take the base of the exponent and bring it down. And then you take the power over here of 8, put it in the parentheses, and that's going to be equal to x. And that's the standard sort of notation for writing this. And as you'll see as we continue, there's certain properties that make writing it in this format to be particularly useful. It's not a useful form for like doing a hard solution, like for actually doing calculations, but it's actually extremely useful for the properties which allow you to kind of work through some very difficult problems. We'll go more over that later. What's really important to know is that you take the base of the exponent, bring it down, and then you just switch the places of the 8 and the x, and so you have 2 to the x equals x. 8 can be written as log base 2 of 8 equals x. Now, it's probably the fundamental property of logarithms, and it might not be obvious. It certainly wasn't obvious to me. Is that if you have something, say, log base 7 of 7 to the 10, and I'm just making up these numbers, that equals x, then solve for x. What wasn't obvious to me is that, look up here. So you have the base, so you have 7 would be the base. So the way to write this would be 7 to the x equals 7 to the 10. That is the same statement. And you want to solve for x. And now when I write it like that, it's really easy to see that x is equal to 10. Written like this, it's a lot less clear. So the one fundamental property of logarithms that you need to keep in mind as we go through this process is that you have a log base 7 and you have inside of that an exponent with a base that's equal to the base of the logarithm. Those things cancel out, and the 10 is just going to come down. Whatever is up here in that exponent spot is going to come down and going to equal the x directly. And as long as you understand that firmly, the rest of learning logarithm properties should be straightforward, and it will greatly expand your abilities as you continue towards calculus and through calculus and beyond.